sir.
Good morning.
Good
Welcome
morning, sir.
to today's lecture. This is lecture number 3, and in this class, what we are going to do, we are going to do reflection at curved surfaces. As I remember, in the previous class, we had done reflection at plane surfaces, or we had done reflection by plane mirror, and we have seen the characteristics of image formed by a plane mirror. Now, I think I have missed one point there, so I'll just add that point in the previous class. And this is, I think, the sheet for the previous class. Characteristics of image formed by plane mirror. We have seen that for a real object, it forms virtual image. The diagram is on your left. For a virtual image, for a virtual object, it forms real image. The distance of the object from the mirror is same as the distance of the image. Height of the object and height of the image are same. We will see how this height of the object and height of the image, if I find the ratio of height of the image by height of the object, that is known as magnification. Magnification in this case is 1. And I told you that we will see how this height of the object, height of the image, distance of the object and distance of the image, they are very closely related to each other. They are related to the magnification of this body. One point I have missed here. And what is that? Now, for a real object, whenever you have a virtual image, now it's very simple to see. When you're looking yourself in the mirror, you are standing erect, and you see yourself in the mirror. The image that is formed is also erect. So for a real object, the virtual image is erect. Do we understand this? If the object is like this, if the object is like this, image will also be like this. So the virtual image is always erect. But if it was a real image, then it would be inverted. A plane mirror cannot form a real image of an object. It can only form virtual image of the object. So if the object is real and it is erect, the image would be erect as well, because it is a virtual image. So that is one thing you should remember, that for a real object, the image would be erect. Do we understand this?
Yes, sir.
Because the image is virtual. That was one point that I think I have missed. So I have clarified it. Now is the time, then we move on to reflection at, I hope you have noted down the point, reflection at curved surfaces. Instead of calling it a curved surface, I could have also called it reflection at spherical surfaces, because most of the surface, in fact, the surface that we are going to deal are going to be spherical in nature. There will be a part of a sphere, and from that concept of part of a sphere, all the definitions of these mirrors of these surfaces will come about. And remember, this chapter is all about remembering the definitions, remembering the small formulas that are there. If you can remember them, because there are a lot of, there are not a lot of formulas. So formulas are very few, but then there are different variations of the same formula. So if you can remember those variations, if you can remember those formulas, it is going to help you a lot in the examination hall, because in the examination hall, you might not be getting enough time to derive the formula that is required. So on that note, let us begin today's class. And since the class says that we have to do image formed by a curved mirror, we have to understand what a curved mirror or a spherical mirror is all about. Sometimes you might call it as a curved mirror, sometimes you might call it as a spherical mirror. Now, as you can see over here, what do you see over here? You see a hollow sphere made up of glass. Do we understand this? So it's like a glass ball. It's a glass ball, but it is hollow from inside. Now, As you can see over here, this is one part of that glass ball. This C is the center of curvature. We can call it the center of the sphere. The center of the sphere is also known as the center of curvature of this mirror that we are going to understand. This P, as you can see, this point P is sort of the center of this mirror. We will call that by some name as well. So basically, whenever we are dealing with curved surfaces or curved mirrors or spherical surfaces or spherical mirrors, in this case, they are part of a sphere. A curved mirror is part of a hollow sphere. You may not write it, you can just mark it. If reflection takes place from the inner surface, and I hope you understand what is the inner surface. This is the inner surface. Do we understand this?
Yes, sir.
This is the inner surface. Inner surface is a surface which is facing the center. Whatever surface is facing the center is the inner surface. The other surface which is outside is the outer surface. If the reflection takes place from the inner surface, then the mirror is called concave. So the other side will be silvered. As you can see in the central diagram, this is a concave mirror. The blue side is the inner side from where reflection takes place. The red side is the outer side, which is silvered or polished, or which is silvered, not polished, which is silvered. Reflection takes place from inner surface. Outer surface is silvered. This type of mirror is known as a convex mirror, the concave mirror. If I reverse the process, I make the silver part inside, and reflection is taking place from the outer surface. Reflection is taking place from the outer surface. I hope you can see this. Reflection is taking place from the outer surface and the inner surface is silver. Such type of mirrors are known as convex mirrors. Both of the mirrors are nothing but part of a hollow glass sphere. Do we understand this?
Yes, sir.
I'll give you a minute to mark this down. You may not draw these diagrams in the notebook because it might be difficult for you to draw it. You can just mark it down because you can just understand it. That is good enough for me. I'll give you a minute. Well then, we'll go through some of the definitions of spherical mirrors. And as I said, we have to understand these definitions. If we understand these definitions, things become a lot easier. The first definition that we'll just go serial wise, is the pole or the vertex. Pole or the vertex denoted by the letter P. Do we see the two P's here? This is nothing but the midpoint P of the mirror. So we just take the midpoint P of the mirror. I've also shown you in the previous diagram, the midpoint P of the mirror is known as the pole of the mirror. Principal section, we don't require this. Any section of the mirror, you take any portion of the mirror, that is known as the principal section. Center of curvature, this is one thing that you must remember. Center of curvature is C. I have marked down the two C's in the concave mirror and the convex mirror. What is this C? Every mirror is a part of a sphere. The center of that sphere is known as the center of curvature. I hope you understand this. Since they are part of a sphere and sphere has a center, sphere also has a radius. The radius R of the sphere, I can mark this as this radius R. Do we understand this? This is also R, and from here to here is also R. We understand this now? It's a part of a sphere. So any distance from the center to the mirror would be equal to R. This R is known as the radius of curvature of the mirror. Principal axis, this line which joins the pole P with the center of curvature, the line CP, is known as the center, the principal axis of the mirror. Here the line is this. Then we have principal focus, focus F. This is marked focus F. Now what is focus F? is the image point on the principal axis for object is at infinity when we have an object which is very, very far away. Wherever you make the image, wherever the image of that object is formed by the mirror, wherever the image of the object is formed by the mirror, when the object is at infinity, is known as focus. Remember, when the object is at infinity, the rays which are coming are parallel to the principal axis. Do we see this? Parallel rays. Whenever you see parallel rays that are coming, those parallel rays are coming from infinity. Wherever those parallel rays converge, or in case of concave mirror, diagram number 1, in case of concave mirror, these rays are converging. In case of diagram number 2, these parallel rays are appearing to diverge. You see, appearing to diverge. Do you see this? Appearing to diverge. That point is known as the principal focus. Do we understand this? Yes or no?
sir. Yes, sir.
You will have to draw this diagram, both of these diagrams,
Okay,
and
sir.
mark everything. You may not write the definition, but you will mark all those points. C, center of curvature. P is the pole. F is the focus. You have to draw. You have to draw. You will have to draw the. You will have to draw the parallel rays of light so that you understand when the rays of lights are parallel. When the rays of light are parallel, that is coming from infinity. I have rubbed everything from the diagram so that you can draw them nicely. Definitions you may not write, but you have to remember the definition. If you can draw the diagram correctly, that means you have understood the definition also. Just for your convenience, what I'll do is I will enhance. I will make the size of the diagram larger so that you would be able to draw them and you would be seeing them on your big screen, which is coming to you right now. These are the two diagrams that we are concerned with. The left hand side diagram is the diagram for the concave mirror, whereas the right hand side is the convex mirror. And I'll give you a minute to do this. Well, I hope you are noting down the diagram. In this diagram, there are two definitions that we have missed. So I'll just show you those two definitions as well. Then you can keep on drawing the diagram. The first definition is for focal length. And I hope all of you know what is focal length, but this is my duty that since we are doing each and every definition, I must tell you what focal length is. Focal length is the distance PF, distance of the focus from the pole P of the mirror. In case of concave lens, it looks a bit different. In case of a convex lens, it looks different, but the definition is same. Aperture. Aperture is the diameter of the reflecting area. So if I draw a diameter like this from M to M dash, this will be the aperture of the mirror. Do we understand this?
Yes, sir.
So these are the other two definitions. You can keep on drawing the diagram. Don't have to write the definition. If you can draw the diagram correctly with all the things written there, there is no need for you to write the definition. If you have understood this, I'll give you time to do that. Have you noted it down?
Yes, sir.
Okay. Then the next thing that we move on, and the more important one, the most important one in this chapter is about sign convention. Now, when I was of your age, we were using two types of sign convention. One was the real and the virtual sign convention, where everything on the real side was positive and everything on the virtual side was negative. There was always a lot of controversy. I was never very good with, or never very confident about that real and virtual system. I don't know why. I used to follow this, and this is the system now. That was the latest system at that point in time. I'm talking about the year 1995. Sign convention, we used to call it Cartesian sign convention. That Cartesian word is gone. So what is this Cartesian sign convention? we are trying to see the convention. Whenever and wherever possible, the first thing that you must understand is the ray of light is taken to travel from left to right. You can see this is left. So unless we make a question where it is specifically traveling from right, it is normally the incident light is always traveling from the left. Do we understand this?
Yes, sir.
Now, since this is a sign convention, we have an origin. This origin is normally the pole P of the mirror. Do we understand this? Origin
Yes, sir.
is normally the pole P of the mirror. Now, if I take pole P of the mirror here, instead of O, I'll call it P. Then I have positive x-axis. Then I have negative x-axis. I have positive y-axis. Then I have negative y-axis. Do we understand this?
Yes, sir.
And that is our sign convention. Anything to the right? Distances are always measured from the pole P. It is not mentioned here, but you have to understand this. Distances above P are positive. Distances below P are negative. Distances are measured from the pole in the direction of light are taken as positive. So basically positive x-axis becomes positive and negative x-axis becomes negative. That is when light is traveling from the left, which is the case. If light is traveling from the right, everything reverses. But one thing that does not reverse is that the direction of light, please mark it, the direction of light along the principal axis in the direction of light, everything is taken as positive. Do we understand this? In most of the cases, light would be traveling from the left. Most of the cases, light will be traveling from the left. So everything here on this side is positive. I hope you understand this. It's just like your XYZ system. This is positive, this is negative, this is positive, and this is negative. I'll give you a minute. You will have to draw this diagram. You'll have to write the sign convention. Remember, distances are always measured from the pole. Above pole positive, below pole negative, right of the pole positive. Light is traveling from the left. Left of pole is negative. I'll give you a minute to note it down.
Okay, sir. Completed, sir.
Okay, it seems we have completed the sign convention. Well done. We move ahead and we move ahead for rules of image formed by a mirror. You would have seen this rule in class 10. We have, okay, to get image from an object, we need two rays which are reflected to be intersecting. So we must draw at least two rays. Do we understand this? We need at least two rays to make a ray diagram. Okay. Now we are going to give you three sets of rule. Out of these three rays, you can draw any two rays. Wherever they meet or wherever they appear to meet, you will get the image at that point. What is the first rule? A ray which is a ray which is parallel to the principal axis, a ray which is parallel to principal axis after reflection from the mirror passes through the focus. In case of a concave mirror, do we see this? Or it will appear
Sir.
to come, or it will appear to come, or it will appear to come from the focus of a convex mirror. This is the first ray that you can always draw, that is always possible. Make a ray which is going parallel to principal axis. After reflection, it has to go through the focus, or it will appear to come from the focus. That is one ray. Now, if we can reverse that ray, what do I mean by reversing that ray? If this ray is passing through focus, diagram number 2, this is diagram number 1, this is diagram number 2. Diagram number 2 is the exact opposite of diagram number 1. In diagram number 1, ray of light was parallel to principal axis. After reflection, it was going through the focus. In diagram number 2, it is passing through the focus. After principal axis, it is becoming parallel. Do we understand this? These are the two rays that you can draw. I want you to write the statement. I want you to draw the diagram. I'll give you 2 minutes to do that. Have you done this, bacha?
Yes, sir.
Okay. Then we come to these two, and we have already discussed this. A ray which passes through the center of curvature, a ray which passes through the center of curvature will always fall at 90 degrees. That means its angle of incidence would be 0. Its angle of reflection would also be 0. So it will retrace its path. Did we discuss this, yes or no? A ray which passes
Yes,
through the
sir.
center of curvature will always fall normally, perpendicularly. Angle of incidence is 0, so it will retrace its path. That is your ray number 3. Ray number 4, remember, angle of incidence is always equal to angle of reflection. Angle of incidence is always equal to angle of incidence. This is law of reflection. If a ray falls on the pole P, here the normal is the principal axis, so whatever angle it falls, the same angle it would be reflected back. Do we understand this? We'll note
Yes, sir.
down these two rays as well. So now you have 4 rays. Out of these 4 rays, you may not have to draw all the 4. You need only 2. Whatever 2 you are comfortable, draw them, make them to intersect. If they are intersecting or appearing to intersect, if they are actually intersecting, it is a real image. If they are appearing to intersect, it is a virtual image. Draw any 2, draw the ray diagram, get the answer, stay happy. I'll give you a
Okay,
minute.
sir.
Give you a minute to note this down. A minute. Everything here is of prime importance because they might give you a simple ray diagram and they might give you what is the final result. They might give you a ray diagram as a question and they might give you what is the correct answer for that. Do you understand? Questions can be made in different ways. So draw the ray diagram.
Yes, sir. Completed, sir.
You completed this. Great.
Yes, sir.
Well done. Now we move ahead and we come to this derivation. The derivation is not required. What is required is that you know the relation between the focus and the radius of curvature, the focal length and the radius of curvature. And I hope all of you know this, that the focal length f is r by 2. So if this is the focal length f, this is the radius of curvature divided by 2. Do we know this formula, yes or no?
Yes, sir.
Note it down. Focal length f is equal to r by 2. Now remember,
Okay, sir.
Now remember one thing you have to understand this. What type of mirror is this?
Concave.
Concave. Okay. All distances are measured from the pole P of the mirror. Now remember the sign convention. The focal length of this mirror would be negative. Yes or no? Why it is
Sir.
negative? It is going towards left. The radius of this curvature, the radius of curvature of a concave mirror is always negative. The focal length is negative, but for a convex mirror, the focal length is positive and the radius of curvature is taken as positive because of our sign convention. Do we understand this?
Yes, sir.
So remember, in optics, wherever you have a formula, that formula has to be applied with proper sign convention. You should not use the value. If the focal length is given as 15, do not use 15. If it is a concave mirror, use minus 15. Wherever, whichever formula you use. Do we understand this?
Yes, sir.
And that is one thing that you should never forget, at least up till the time you are appearing for your NEET exam. After that, it's up to you if you want to forget it or not. What next? This is the next one. Relation between U, V, and F for a curved mirror. We call it the mirror formula. We all know this mirror formula, yes or no?
Yes, sir.
Now, let me just go through it once again for my mental satisfaction, that I have explained the various terms that are appearing in this diagram. This is just for my mental peace. Do you see this diagram on the bigger screen? Yes or no?
Yes, sir.
Okay. What is this? O is the
Object. Object.
Good. What is this C?
Center of curvature.
Good. What is this I?
Incident ray.
I is the incident ray.
Image.
Image. What is this P?
Principal axis. Pole. Pole, sir.
Pole. Pole. What is this? This is the principal axis. Do you understand this? You understand this?
Yes, sir.
Okay. What is this?
Focal length.
This is U, not U. U is the distance of the object from the mirror. Do we understand this? Did I tell you that in plane mirrors or not? U is the distance of the object from the mirror. Yes or no?
Sir.
So here U is the distance of this object O from the pole P of the mirror. Remember, all distances are measured from the pole P of the mirror. OP is the distance of the object from the mirror, and the distance of object from the mirror is always taken as U. Do we understand this?
Yes, sir.
Raise hands. Okay. Since we know U, then we know V. First comes U, then comes V. V, W-E-V. Not W-E-V, it is V. What does V stand for here?
Focal length.
Why will I call focal length as V? Our focal length does not start from V. V is the distance of,
Distance of
I,
image.
distance of the image from the pole P of the mirror. Do we understand this?
Yes, sir.
Okay. Now, the focus is not drawn here. The focus would be somewhere. Focus is definitely somewhere. What is this R? What is this R?
Radius of curvature.
This R is the radius of curvature. Now, there are three angles given, and this is just for if a very tough question comes. This angle is alpha, which the incident ray is making with the principal axis. Do we understand this?
Sir.
This is the angle gamma, which the reflected ray is making with the principal axis, and this is beta. Beta is the angle that the principal axis, the line drawn from principal axis makes with this point where the ray is falling. So you should draw this diagram. I will rub everything off so that the diagram looks clean. You have to draw this diagram. Without this
Okay, sir.
diagram, nothing works. So I'll just rub this off for your convenience. I hope I have marked everything correctly. Alpha, beta, gamma, all the angles are marked, all the points are marked, U, V, and F are marked. Now the diagram is clean as it was. Oops. Draw this diagram, draw all the angles.
Okay, sir.
Theta may not be required, but alpha, beta, and gamma are required for a question that comes and it is difficult. O, C, I, P, M, U, R, V. These are the important points that has to be drawn in the diagram. Please draw it.
Okay, sir. Completed, sir.
Okay, that's great. You've drawn the angles, you have drawn the other things, then come the most important aspect, and it is the formula that you must remember. I hope you can see these formulae. I'll mark them. This is formula number 1. 2 beta is equal to gamma plus alpha. You will not find this anywhere, and we might skip it sometimes. Sometimes we think that the things are not very important and we seem to skip them, but this is an important formula. If a tough question comes, that is how they make the tough question.
Okay, sir.
2 beta is alpha plus gamma. You know the angle alpha. Alpha was the angle with the incident ray. Gamma was the angle with the reflected ray. I hope you can see it in your sheet. And beta was the angle with the center of curvature. Then 2 by r, again, this is the formula in terms of radius of curvature. 2 by r is 1 by v plus 1 by u. Remember, whatever formula we have used, they have to use with proper sign convention. Do we understand this?
Yes, sir.
Well done, sir. Similarly, if we write the formula, the mirror formula in terms of the focal length, it becomes 1 by f is equal to 1 by u plus 1 by v. All the formulas that we have seen must be used with proper sign convention. Note down these formulae.
Okay, sir. Completed, sir.
Well done. Good. Now, I told you something about magnification. Magnification is how big or how small you see the image. If you use a magnifying glass, and you would be using a lot of magnifying glass and a lot of microscopes to see small things, smaller things that are neglected. Magnification basically means that this is of your use. Magnification basically means how small or how big a thing is. How do I define magnification? And here comes the formula. Linear magnification is what we are talking about. Size of the image divided by the size of the object. Do we understand this? It's a very simple thing, nothing very complicated about it. How much the object has been magnified in terms of the image, the size of the image divided by the size of the object, and the diagram is already there. You must draw this diagram. This, as you can see, is an object, erect object. And as you can see, the image is inverted. Now that's a real image. Do we understand this? For a
Yes, sir.
erect object, the image would be, if the image is real, it would be inverted. The diagram is drawn, is there, that you can draw the diagram. As you can see, this h1 or hi is the height of the object. Do you see this?
Yes, sir.
h2 is the height of the image. That is from here to here. That is the height of the image, inverted image. Now, when you do the calculation, simple maths, ray optics is known as ray optics. Ray is a term that is used in maths. A ray is a line segment which has one endpoint and it extends to infinity. Because this is all about math, this is all about geometry. From geometry, we can get a very simple formula for magnification, and the simple formula for magnification comes as minus v by u for a mirror. This is a formula that you should never forget. The formula of magnification by a mirror, and it is equal to minus V by U. Remember, V and U must be used with proper sign convention. Do we understand this?
Yes, sir.
So what are the formulas that you must remember? Formula number one is the definition of magnification, height of the image divided by the height of the object. Formula number two is the formula that we have derived from the above relation, minus V by U. Remember, all these formulae are derivable from each other. They are not independent formulae. Formula is only one, height of the image divided by the height of the object, and all the other formulas can be derived from this. Do we understand this?
Yes, sir.
Whatever I am noting down, I'm marking in a box. This is very important and you must remember this. I will give you a minute to note these two formulae first, together with the diagram.
Completed, sir.
That's good work. You have completed the basic formulae, and as I told you, the number of formulae in this chapter becomes a lot more because they can be given in terms of other things, and that is how I'm going to explain what you are going to see on the screen now. Now,
Yes, sir.
as you can see, m is equal to minus v by u. M is equal to minus v by u. You have already seen this formula, yes or no?
Yes, sir.
What is v here?
Distance of image.
From where?
Object.
Distance of image from the object. Hey, Bhagwan.
Mirror, sir.
From the pole of the mirror, right? What is u?
Distance of object.
From where? From
Distance
the
of object.
from where? From where? From the pole P of the mirror. This is one formula that you have seen, and that is equal to h2 by h1. What is this h2? Bacha.
Height.
Height of what?
Height of image.
What is h1?
Height of object.
Great. So you see v u, the red box, is equal to v by u minus v by u is equal to h2 by h1. Distance of the image from the mirror, pole of the mirror, distance of the object from the pole of the mirror, height of the image and height of the object. Do you understand that they are related to each other?
Yes, sir.
How they are related? Minus v by u minus v by u. Look at this formula. Minus v by u is equal to h2 by h1. Do we see this?
Yes, sir.
Do you remember something that I had told you in the previous class, also in the beginning of this class? Does anyone remember it? Does anyone remember it? What I had said in the beginning of the class? Does anyone remember it?
No, sir.
No, sir. That is the problem, sir. That you don't remember, sir. If you can remember it, sir, that would be very nice, sir. Problem is we
Sure.
don't remember it, sir. And this thing has disappeared, so I'll just try to get it back. Sometimes things happen and you don't know why they are happening. Everything is a machine, and a machine may malfunction as what human brain does. Okay, since you have forgotten, this is how I will make you remember this. Did you see that green arrow that I had drawn in the previous class? And I also told you that they are related to each other. Yes or no?
Yes, sir.
Distance of the object, distance of the image, height of the object and height of the image, they are related to each other. Yes or no?
Yes, sir.
And what we have seen just now, what we have seen just now is magnification for a mirror is minus v by u, where v is the image of the object, v is the distance of the object, u is the distance of the image, and that is equal to h2 by h1. This is how these things are related to each one. H2 standing for the height of the image, h1 standing for the height of the object. Do we understand this? So that is how you relate it for what you had done in the previous class. So if you don't study in the previous class, bacha, you will be at sea and you would be sending SOS messages, which are the last thing that you should do. Please remember it. Don't forget it. Can I trust you now?
Okay, sir. Yes, sir.
Note it down, and then I'll take you back to the screen that I was talking about. Note this down. This is how we, you, with proper sign convention, minus v by u is equal to h2 by h1. I hope you have noted it down. Then I take you back to the screen that I was talking about. Minus v by u is h2 by h1. Now what they have done, is this formula, which I will now call it as formula number 3. So that formula number 3, let me use a different color so that I'm a colorful person, so I use different colors. Though I wear only 2, black or blue or white. Okay, the green formula is the formula of magnification in terms of u and f. If you can remember it, it's good. Otherwise, you can always find v from u. using the mirror formula and then put it in the original formula. Do we understand this?
Yes, sir.
So this green formula is formula number 3. If I can put 3 here. This green formula is formula number 3. Same formula, instead of minus v by u, v has been eliminated. This formula is in terms of f and u. Similarly, the other formula is f minus v by f. I shall call it formula number 4. Remember formula number 1. If I could call them this, if I call formula number 1, if I could call this as formula number 2, then 3, then 4. Remember, they are not independent formulae. They are same formulae but written in different ways. You can remember all 4 of these. Well, you would be able to solve questions more swiftly, more quickly, and that is what your exam is all about. I'll give you a minute
Yes, sir.
to note this down.
Done, sir.
Done, sir? Then it is very well done, sir. Now, again, this chapter is everything about how many formulae we can remember and in what different forms can we remember, and this is a synopsis of what can happen if the image is real. Now if the image is real, it will be coming on the real side, same side of the mirror, so u will be negative, at the same time v will be also negative. Do we understand this?
Yes,
Negative
sir.
divided by negative is positive, but then again I have a negative sign over here, so the entire result would be negative. That means for a real image which is always inverted, if I write it in terms of H2 and H1, H2 would be negative because it is inverted, H1 is positive because it is erect. The magnification for a real image will always come as negative. Do we understand this?
Yes, sir.
H1, which is the height of the object, H1, what they have done here. Forget about this. You might get confused, so forget about this. Just take this out. Okay. So for a real image, the magnification will be coming as negative, while for a virtual image, which I shall write in red, what will happen for a virtual image? What will be the magnification coming for a virtual image? It will be minus v by u. V will be coming on the other side, so it will be positive. U will be on the same side, which will be negative. Remember, in most of the cases, U is negative. So for a virtual image, the magnification will be coming as positive. Image will be erect. You can see this. Erect image, yes or no for an erect object?
Yes, sir.
Both are standing, so both are positive. Positive divided by positive is also positive. So for a virtual image, the magnification will be coming as positive. For a real image, the magnification would be coming as negative. Do we understand this? Take this out. You might be confused. Real image is always inverted. A virtual image is always erect. I'll give you a minute to win it. Have you done this, bacha?
Yes, sir.
Are you laughing? Do we understand this, everyone? Can I have raise hands from everyone that we understand this? Okay. Now
Yes, sir.
this was the magnification which was known as linear magnification, or sometimes it is known as transverse magnification. Oops, you might be hearing these terms and or lateral magnification. Okay, so don't get confused. You might hear a lot of terms. Don't get confused. Just stay confident. So whatever magnification we had seen, where this was the principal axis and the object was placed like this. Do we understand this?
Yes, sir.
This is what we call linear magnification. Magnification is always height of the image. How much is the image divided by height of the object? This type of magnification, when the principal axis is like this and I plate the object like this, so they are at 90 degrees to each other. Do we understand this? They are perpendicular to each other. Then the magnification that we have created or we have found out is the height of the image divided by the height of the object. This is known as the transverse or the lateral magnification. Do not get confused by the terms. Transverse or lateral or whatever you call linear is height of the image divided by height of the object. It is always come as minus v by u. Do we understand it?
Yes, sir.
That is the magnification that we have studied just now. How can things be different? Can there be a different type of a magnification? Yes or no? No or yes? No. To answer this question, what I have to do is, let me do it with this. Let me do it with this color. Okay, let us say this is the principal axis and this is my mirror. And which type of mirror I am drawing here? Correct? Which type of mirror is this?
Concave, sir.
Concave, sir. Okay. Now, if I place the body like this, the image will come like this, inverted or whatever. What if if I place the object along the principal axis? So this is the bottom, I call it the tail, and this is the head. Do we understand this?
Yes, sir.
So far so good. Now since the object is like this, I have two types of distance of the object. I can call this as u2, distance of the end A, and then I can call this as u1. Do we understand this?
Yes.
Now, depending on where this object is placed, the image can come in different ways. I'll just draw one. I'm just not going theoretical here. I will draw it with which color? My green color is my favorite. Let us say that the image comes like this. So this becomes my A dash and this becomes my B dash. Do we understand this? The image comes like this.
Yes, sir.
So we'll have a distance of the end A, the image wala end A dash, and I will also have distance of the end B dash, which is the other point. That will be V2 minus V1. So in this case, the magnification, the lateral magnification will be written like this: V2 minus V1. V2 minus V1 is the length of the image. Do we understand this?
Yes, sir.
Divided by U2 minus U1, which is the length of the object. I'm not calling it height because height is like this. This is length, this is height, this is length. So I'm calling it the length of the object divided by length of the, length of the image divided by the length of the object. Do we understand this?
Yes, sir.
V2 minus V1 divided by U2 minus U1, or you can also write this lateral magnification as delta V, difference in V divided by delta U, difference in U. Do we understand this?
Yes.
Now, I'll give you a minute to note it down till here. I only want you to note down the formulae, why I'm babbling so much, why I'm describing so much, so that the point becomes clear and you don't get confused. So I'll give you a minute to digest what I have told you just now, and then I'll come back. Have you noted it down, beta?
Yes, sir.
Then let's move on, sir. Now, this magnification that we had seen, now we are going to call it transverse magnification, MT. Do we understand this? We have already seen its formula. What we are discussing here is the black variation, ML, longitudinal magnification. Do we understand this? Yes or no?
Yes, sir.
That is again equal to the length of the image, Li divided by Lo. Why we're taking L? So that you understand it is the length of the image. This I can write it as Hi, height of the image divided by height of the object. Do you understand the difference between H and L? So that will be V2 minus V1 divided by U2 minus U1. Do we understand this?
Yes, sir.
That will be written as difference in V or change in V divided by a change in U. Got this? Now, if the object is very small, the above formula can be replaced by a different formula. If an object is very small, remember the formula that we are writing is only for object which is very small. This magnification, which is in terms of formula minus delta V by minus U. Oh, it's not minus delta V, sorry. It's delta V by delta U. That can be written as dV by du. Do we understand this?
Yes, sir.
dV by du, where dV stands for the change in the value of V, and du stands for the change in the value of U. Do we understand this?
Yes, sir.
Yes, sir. I think I made a mistake here. Here I should have written a negative sign, which I forgot. Here I should also have written a negative sign, which I forgot. Minus dV by du. Do you understand this? So minus dV by du is the formula for objects which are very small. Do we understand this?
Yes, sir.
Now this minus dV by du can be written in a different way, and that different way is it can be written as V by U ka squared. And I will not tell you how it is derived. You can just write it like this: minus V by U ka squared, and that becomes your MT ka squared. So your ML actually becomes MT ka squared in terms of value. This is what I want you to write down. Remember, this is only for small objects. For large objects, ML, the longitudinal magnification is V2 minus V1 divided by U2 minus U1 minus delta V by delta U. For small object becomes minus dV by du, and that becomes V by U ka squared. That becomes MT ka squared. So longitudinal magnification is the square. The value in terms of value, it is square the value of the transverse magnification. I'll give you a minute to note this down.
Okay, sir.
Shall we move ahead?
Yes, sir.
Okay, that takes us to almost the last part of the today's class, superficial expansion or aerial expansion. If I have a two-dimensional object, do you see this two-dimensional object? Do you see this? Yes or no? No or yes?
Yes.
Shall magnify it so that you can see it in broad daylight. I'll just keep it like this. I hope you can see this now on your big screens. Where is that? Okay. It has
Sir.
an an height, it has a width. Yes or no? HO, height of the object,
Yes,
WO,
sir.
width of the object. Then I have H dash, which is the height of the image, which will be M times height of the object. Then I will have W dash or WI, which is M times W naught. Do we understand this?
Yes, sir.
Yes, sir. No, sir. Then, sir, if I want to find out the area of this image, sir, I mean the magnification of this object, sir, then what do I do, sir? What do I do, sir? We call such magnification as superficial or aerial magnification. To find out the superficial or the aerial magnification, we use the formula area of the image divided by area of the object. Is it clear? So it is M times
Yes, sir.
height of the image, M times height of the object divided by height of the object into width of the object. So this aerial magnification MA simply becomes M square. This is the formula that I want you to write down together with this graph. You can draw this graph. It is, if you can draw this diagram, it is abundantly clear from this diagram. You can also highlight this point. Area of the image is M square into area of the object. Everything points out to the same thing, that the magnification of this gentleman is simply equal to M square. Do you understand this?
Yes, sir.
I'll give you a minute to note this down.
Okay, sir.
I hope you have noted down the formula, bacha.
Yes, sir.
Aerial or superficial expansion. We have heard in this chapter of expansion, aerial expansion, expansion in area. This is aerial magnification, the magnification of the image. That takes us to the last part of today's class. If we have more than one optical equipment, optical component means mirror, lens, whatever. If I have one mirror, one one mirror, two mirror, three mirrors, and I have image formed by reflection or refraction from multiple mirrors or one mirror, one lens or whatever, then the image formed by the first mirror will act as the object for the second mirror. The image formed by the second mirror will act as object for the third mirror, and so on. Do we understand this? If we have
sir.
if we have two lens, the first lens will form the image. That image will act as object for the second lens, and so on. So the total magnification will be the height of the final image divided by the height of the original object. Do we understand this? Now, if I write the formula for a number of mirrors or number of lenses, it will be M1, the magnification of first one, multiplied by the magnification of M2 multiplied by M3, and so on. So basically, magnification gets multiplied. Do we understand this? I'll give you a minute to note this down. Everyone understands this?
Yes, sir.
Please raise your hands, everyone. Okay. Note this down. Once you have noted this down, we are done with the class. I'll give you a minute.
Okay, sir.
Have you noted it down, bacha? Everyone?
Yes, sir.
Well, then congratulations. We are done with today's class. What we have done in today's class? In today's class, just to give you a brief picture, we have dealt with what are curved mirrors or spherical mirrors. Two types of spherical mirrors, concave and convex. In concave mirror, we have the inner side which is reflecting and the outer side which is silvered. In convex, we have outer side as reflecting and the inner side as silvered. We have seen different terms. Center of curvature is the center of the sphere. Radius of curvature is the radius of the sphere. Pole P is the center of the mirror. F is the point where parallel rays will converge after reflection. Focal length is the distance of focus from the pole P. All distances are measured from the pole P. Distances in the direction of light are positive. Normally light is coming from the left. So positive x-axis is positive, negative x-axis is negative, positive y-axis is positive, and negative y-axis is negative. We have seen the relation between focal length and the radius of curvature f is equal to r by 2 with the sign convention. We have seen the mirror formula 1 by v plus 1 by u is equal to 1 by f or 2 by r. We have also seen 2 times beta is gamma plus alpha. You must remember what is gamma, what is alpha. We have seen what is magnification, height of the image divided by height of the object. We have seen transverse magnification minus v by u. We have seen lateral magnification minus dv by du, which is nothing but transverse magnification square. We have seen aerial magnification, which is also transverse magnification square. And the last we have seen, if we have a number of optical instruments, the total magnification is the multiplication of the magnifications. In the next class, we will undergo different cases of image formed by different mirrors. So if you can go through them before coming to the class tomorrow, it will be of great help. We'll meet you tomorrow, same time. I hope you all stay well. Take care.
Yes, sir.
Have a nice
Thank you,
day,
sir.
and I will wind off this class now. Bye bye.
Tata, bye bye.
Bye bye.